Here's a Bell Howell School's Vry Institute of Technology transistorized analog meter. And this has been sitting around in the barn for a long time, and I thought I'd get it out and see if I can get it working here. I don't know what the condition of it is. I guess we'll have to find out. So, next step will be to open it up and check out the innards. Stand by. I'm not sure what the connections are for this. I try to find some information on the internet, but there isn't much. It has 4 wires that evidently went to the batteries that power the unit. I'm going to assume that black and red are the power for the meter, and the yellow and blue are for the ohm meter function. At least I'm guessing. Now, when I opened this up originally, there were some batteries in a box, and they were leaking. There was 3 D cells. So I'm assuming that those were for the power. So I'm going to set a variable power supply for 4.5 volts. And I'm going to connect the red and the black to 4.5 volts. See what happens. If anything else, we'll get smoke. I got it current. Oh, something moved. Oh, there we go. Battery. It's within. Let's see. I'm going to vary the voltage. There's 2.2 volts. Right in the middle of the battery adjust, there's a little green mark that says battery adjust, and I've got that on 4.2 volts. So let me prop this up somehow. And let's see if this will measure anything. Here's an old lithium cell out of a laptop battery. Should be about 4 volts. So we'll put it on positive 4 volts, or positive times 10. Oh, look at that. 3.8 volts. Okay. So now, see if we can run this. Okay, the 0 control works. So now let's see if we can get the ohm meter to function here. So I'm going to connect a battery up to the blue and yellow leads. And I'll connect a 1.5 volt battery to those 2 terminals. And now I'll short the 2 leads together, and we should get deflection when I do that. Oh, and we do. Okay, let's see if we can set the ohms. Ohms to 0 and to infinity. Okay, that's working. Well, if I can get this working, maybe we can calibrate it. Let me find a resistor. We'll measure the resistance. Okay, I found a resistor here. Brown, gray, red. That sounds like 1800 ohms to me. 1.8K. So Let's see, I'll put it times 100. Yeah. 1.8K, it doesn't look, well, let's see. Yeah, it doesn't look bad here. Let's try the other scale. Well, it's a little off, but that can probably be adjusted. 1.8K would, well, that's pretty close. 1 point is just below 2K, so it looks good. Let's try another resistor. Here's what's this one? $560 ohms. Green, blue, black, brown. Green, blue, brown. Sounds right. We'll change our range here. $560. Boy, that's pretty close. I think this meter's going to work. All it needs is a power supply. 4.5 volts and 1 volt. Maybe we can. I'm going to measure and see if that negative is common. Maybe I can put 4 volts or 4 cells in series and then tap off one of them. But only if that negative is common. I'll check that next. So for now, I'm going to disconnect all of this. This will give me a chance to check out my new Kaiweets. Yeah, what a deal. Look at that baby. Wish it was a fluke. Oh well, can't have everything. So let's measure between black and blue. Hopefully. No joy. So it looks like they don't share a common ground. So I'll have to have a separate voltage for ohms. I don't think I'm going to use this for resistance anyway. So I think what I'll do is just put 4 D cell or 3 D cells in series, or even C cells, and then go from there. Let's see how much current this thing uses. Okay, that's about 4.5 milliamps. Alright, let's see what the let's see what our new Spangle Kaiweets says. .78 milliamps. Not too much. So you don't need a fluke meter. These are just as nice. I don't think I'd want to drop this one. But it isn't really too bad. It's got a... Well, I'm not doing a review on this. I just bought this the other day. But it seems to be well made. It's got a light on it and everything. So, since I'm not going to use the ohm meter, I'm going to power this from 3 1.5 volt batteries and just use it for voltage. That's all I'll really use it for. I like the idea that it's got a zero center meter, so that comes in handy. Anyway, that is the next step. Well, I changed my mind. Here's a little update. I'm not going to use 3 D cells or C cells. I'm going to use 1 lithium cell. This is out of an old laptop. I collect these things by the dozens. Get old laptop batteries, you're going to find good cells in them. Some of these are really good shape. Anyway, I'm going to power this from a lithium cell, and as you can see, without the glare, the battery is just fine. So that's the next step. When you get anything from a Hamfest or anything else, always check it out really good. Look what I found inside of this little cardboard box the batteries were in. Somebody was nice enough to draw a wiring diagram. And this is old, the paper's turning yellow, so there you go, 3 D cells and a C cell. Sells seashells by the seashore. Anyway, we're just going to use 4.5 volts. Anyway, just a little slight update. Okay, I'm running the meter on a lithium battery, and we can check the battery. It's within the adjust green. So plus volts. I've got a variable supply up here on 1 volt. You can see it on the digital voltmeter. We got 1 volt. Go to range times 10. We got 1 volt. So let's run the voltage up. To about 5. There's 5, pretty close. And there's 5. And we'll run it up to 10. It's easier to adjust an analog meter than a digital meter. Not as accurate, but okay, there's about 10, 9.9. Give it another vernier here. And there's 10 volts. Times 100. Well, we're off just a hair. Pretty close. Let's run it up to what this little supply will do, pretty close to 30. There's 30 volts. And boy, there's 30 volts. This little thing's accurate. Right now I'm just running it off of a lithium battery. I am going to, in fact I ordered some single cell 18650 battery holders, and I'll mount that on here. In fact, I might mount it on the outside so I can change it easier. But anyway, it's a nice little meter. I got this at a Hamfest years ago, and it was sitting in the pile, and I thought I better do something with it. So here times 1,000. Can't do that. 30 volts. 30 volts. Anyway, that's the little Vry Bell Howell School's voltmeter that wanted to be a VTVM, but it became a transistorized voltmeter. I believe they built these from kits back in the day, if I remember right. Look at transistor sockets. I'm not going to put in a battery for ohms. At least I don't think so. I doubt I'll use a signal measure resistance. So anyway, hope you enjoyed it. See you in the next one. Thanks for watching.